Hi everyone. Just wanted to do the weekly update. So I wanted to cover these topics at least, and maybe more if I can think of them. But the first thing that I worked on was the parser. So this is for my Lisp, which I've called mill, stands for my Lisp. Last time we did the lexer. Let me make this bigger. We did the lexer, and so this time I worked on the parser. So Lisp is pretty particularly easy to parse Lisp-like languages. So it's not a very complete parser. Notably, I don't even have symbol support yet, but I don't think that should be that big of a deal to add. So I mean, obviously you have the ints and the floats and the nil, that sort of stuff. Uh, Pretty much, except for nil, some special cases there. But like the int and the float, that's just straight from the lexer. If you see a token that's that kind, just immediately parse it into the um, AST node, right? Just promote it to an AST node basically. And you're not adding any extra information really. So the cons is the real one, and that makes sense. This is a Lisp. So if you don't know, a cons is a cons is a fundamental operation in Lisps, and what it does is promotes. So cons. Let me do it like this, maybe cons a b. So what it will do is promote a to, maybe I should say, create a list with car a, which I guess we could say head. If you don't know, car is just the Lispy way to say the head of the list. First item, I think it stands for currently addressable register or something like that. And with car A and CDR, aka tail B. Right, so this, of course, is the interpretation of a list as is an inductively defined data structure, I guess. A list is a head and a tail. The head is the element, and the tail is like another list, right? So if you had, so if I just had the list like 1, 2, 3, then you can interpret this as a instead of viewing it like a vector where it's just a contiguous region of memory where the first slot is 1, the second slot is 2, the third slot is 3, you say, okay, the head of the list is 1, and so this is kind of like a linked list. And then, so the car is 1, and the CDR is the list 2, 3. And this is useful for like recursive algorithms, right? You treat the rest of the list as a list. So notably, like in the above example, like this list is not equal to cons AB, right? Because here the car is A and the CDR is actually the list whose single element is B. And so like the list whose single element is B is not the same as the element B, right? This is actually a list whose car is B and whose CDR is nil, or I should say the empty list. Yeah. those two are sometimes interchangeable, nil and the empty list. So yeah, so that's the fundamental thing. And then so if you have like a complex, you have like a more complex thing, like let's say we're defining a function, define foo a b and just plus a b. So you just define this like as a cons. You parse this as a cons. Because there's no special syntax here, right? What this should become is like if I were to write this out explicitly, so a shorthand for cons a b is also a dot b, but maybe I won't write it like that. So what do we see here? So this is the same as cons defun, the symbol defun, and the tail is the list foo a b. I'll just leave out the symbol the quotations just for simplicity, plus a b. Yeah, so that's that. And then so you parse recursively. So this is also a cons, which is like that. And now this is a cons, right? Which is like that. Cons. And then yeah, and like so on like that, you know. So all of that is to say, like, the really only difficult thing here is the cons. And since it's recursively defined, you kind of have to do some stuff to actually store a cons node. You don't really know the type of the thing that's going to be the car or the CDR, so you don't know the size, so you have to box it into a unique pointer. And a unique pointer in C++ it works well because it allows us to like maintain ownership. We don't have to create it somewhere and worry about freeing it. So you do that, and then there is like a little bit of annoyances that if I go to the implementation, like I spent a lot of time, not a lot of time, more time than I'd like to admit, I guess, trying to get these like move semantics to work, right? So like if we parse this S expression and we want to store it in the we want to store it in the cons node, you have to like move it there. Yeah. So, yeah, I like this too. So if I was at work, probably someone would be like, "Oh, you should just use a reference here. Like, why use a pointer if you don't have to?" I don't know. To me, especially when we're talking about move semantics, if you're not working with the pointer and you're just like, at least like, you know, syntactically, you're just like writing the just this, then it kind of gets confusing, like what the move semantics are. Like if you're just yeah, so I just thought like it's just simpler to deal with the pointer itself. I mean, a lot of times I don't like the implicitness, I guess, of references. I like the benefits that they provide, and I actually do see the benefits of, you know, not having a special syntax for working with them, but at least I would like to have a special syntax for creating them. So like if this was to be a reference, then the way I would do this is I would just do it like that. And then this would implicitly create a reference. But like if I did this, and I don't really think this would work actually, but if I did this, then you're actually calling like the copy constructor. But if you do this, this is just taking the reference, which is not copying anything. But, you know, especially in the terms of a function call, and you're passing in a parameter that's a reference, and you just see this, then From when I'm reading the code, it just kind of looks like that. It just looks like I'm moving it or copying it, I should say. So I just wish like you could also use this syntax for it, but in lieu of that, I sometimes just like to use pointers instead. And this is my own code, so no one else to tell me that it's bad practice, right? So then, just use my testing framework that I had talked about last week to test a few cases. As I was explaining the parsing, I was like, oh, there might be some edge cases I didn't consider. But I'll deal with those as they come. Like I said, I find parsing really dull. But now, like if I'm pretty close to having an AST, I am excited to start working on the backend and generating code and finally like being able to write code. Maybe that's a little bit far off, but optimistically, I'm going to say it's not that far off. Kill anyway, yes. And kill anyway, I don't want to save this, yes. So that was the parser. Next, like I was saying, like we pretty close to writing a backend. So the backend, that's how we can take the AST representation and go to generate code, execute code. There are several approaches I am thinking of. One is, so let me preface this by saying like what the difficulties are in a Lisp, especially this sort of Lisp. Interactive development. If you saw how I was developing the Common Lisp program from last week, if you've developed Common Lisp or eLisp, you see how I modify my config while my Emacs is running. You'll know that Lisps can execute, you can redefine things, execute things at runtime. When I first saw that, I thought that was just magical. I couldn't understand why we don't do that more. That seems sort of a forgotten feature in modern languages. If you've ever seen SBCL, which is the standard Common Lisp compiler, they are actually able to provide that functionality while still compiling to native code. Now, obviously, like you're redefining a function, so there's something going on there. If you redefine a function, maybe I should write this in the Scratch, right? Like, what does it entail to redefine a function at runtime? That means that, well, first we should maybe talk about calling a function that is redefinable. So you either have to replace the symbol itself, we're talking about native compiled code here, replace the original symbol, and then you have to also update the call sites, right? Depending on how you do it, especially if you define a new symbol. If you don't want to update all the call sites, which might be expensive, what you can do is instead have call the function, calling a redefinable function results in a symbol lookup. So the runtime maintains a mapping of like function names to the symbol. And so when you redefine a function, you're just changing that mapping to your new symbol, the new function you just defined. That does come with the overhead of having to look up that symbol every time you call the function. So there's that level of indirection. However, It's not always as bad as it sounds, especially if you're aware of it. Um, and in Common Lisp, that's how like all pretty much all functions are. SPCL is able to natively define the functions, but they do this sort of dynamic lookup for functions, and that's how they do it. But it's still pretty impressive that they can generate native code that's executable like while the program is running. And on a side note, one of my ideas for my Lisp is to have static functions. So I'm thinking all functions, as in Common Lisp, will be redefinable or dynamic by default, which means you can redefine them in particular. But sometimes you don't want that level of indirection. And so you should be able to say, hey, this is a static function. You can't redefine it. But that means like you, the compiler, can just insert the symbol right there. You don't need to do this lookup and therefore remove that level of indirection. I don't think that needs to be the default. There's one thing that I appreciate about the Common Lisp community, at least I've learned, I should say, is that things that you think are a problem are not necessarily problems in your use case, and you should profile it and then change it when needed. So this is often talked about like, oh, Common Lisp, it's garbage collected, it's doing all these dynamic function lookups, stuff like that. It surely is not that efficient, but hey, I mean, SPCL is extremely efficient. By natively compiling functions and still maintaining like this dynamic behavior, maintaining the garbage collector, you can get quite good performance. You might not expect that. And so I think it's best to have dynamic functions by default. Also, like, you don't know when you want to redefine a function. Like, let's say you're just coding and launch your program, you're hacking away on it, something breaks. You didn't expect it to break, but now you want to go redefine it. You don't want it to have been static by default and now you can't go redefine it. You would have to go make it dynamic, relaunch your program, then do it. You don't want to do that, I think. SBCL has convinced me that if everything is dynamic by default, the performance is good enough most of the time. You profile your program, you see this level of indirection is actually significant, causing significant performance overhead at that time, make it static. Yeah, and in terms of the backend, right? I'm thinking for releases, there should be a way to just compile a program completely statically and sort of have debugging or interactive development as a developer build feature. So, and like if you saw the Common Lisp thing, it's kind of annoying to create Common Lisp executables. Part of that and the size, like executables 40 megabytes for a simple CLI program because they have to package a whole compiler in there. You should be able to say, I think, that you don't want this interactive thing in your release build, and just then everything can also be all the dynamic functions could be made static too, so you also get that performance gain. So backends, right? So there was 3 backends I was heavily considering. So one was LLVM. LLVM has an ORC, Orc API, which stands for On Request Compilation. It's their JIT API. I don't have a lot of experience with it. Even that is sounding generous. I don't have any experience with it. I've just like read about it a bit, looked at some examples, watched a few videos. But that seems like it should be able to do what we're asking. This function redefinition, this interactive development thing, what it's revealed to me is that this is really a problem of linking. The problem is, how can you create new code, link it back in, deal with like the symbol lookups. This is really a linking problem, and that's what Orc realizes as well. That's what I've learned from Orc. And so that's one approach. But you know me, like, having such a huge dependency, I don't like. LVM API is changing a lot, which maybe is not that big of a deal, but I don't like that either. I'd like for, and the Orc isn't like super widely available on all platforms, not that that matters either, but just pointing it out. If I really want like a self-contained language, then the best way I think to do it is to write a VM. And yeah, then you deal with the linking stuff in your own way, in the way specific to the VM you write. So I think regardless of if I want native compilation, I think I should have like a VM, and it would be good, at least for debugging or development. But I'm hope that it will be performant enough to be like the standard driver. The other option is to transpile to C or C++. A lot of people do C for, I think, not just portability, but also the speed of the compilation. Transpiling in any form is going to be slower, I think, because you're going to have to reach out to a native program. You're going to have to go through all the parsing again in the language you're transpiling to, and then it'll compile it, right? C++ is much slower to compile, but you get C++ features like classes, move semantics, that sort of stuff. That sort of stuff is useful. So I'm actually leaning towards transpiling to C++. In both cases, you get the C API for free, so it's pretty straightforward to call C code, right? You just insert a call into your generated code. So the transpiling, I think, I definitely want to do, because I think that's the fastest way to get from where I am to actually executing code. It's quite hard to do the dynamic programming there. So you might only have support for this production release build that has no dynamic interactive programming capabilities if you're choosing the transpiling backend. But that's okay, like we'll get something up and running, and I think that's good. It's hard to do the dynamic linking stuff, and that's why this LVM org exists. Maybe not why, but that's if it was easy, like maybe this wouldn't need to exist, is I guess what I'm saying. So actually there's a common Lisp compiler, ECL, which compiles common Lisp to C, but it still has this dynamic interactive programming capability because that's part of the common Lisp standard. I don't know really how they do that. I looked it up on, I don't know if you could say I looked it up, but I asked ChatGPT about it and said like maybe it has a VM. I would like to know more about that. But that would be one way to do it. Maybe you could, all the code that is static, you can compile to compile natively, but then you have to package in a runtime. And that runtime would include a VM, and any code you compile at runtime would be compiled down to bytecode and run on the VM. Or maybe all code works like that in ECL, I'm not sure. So Yeah, so I mean, I just started work on the VM. I think it's a little bit interesting actually. Um, oh, and I should say, like, I think it would be cool to have at least one native backend. I develop on an M1 Mac, so I think it would be a fun exercise at least to have a native backend and probably only support like static stuff, sort of like the C transpiling. I'm sort of leaning away from the LLVM org at the moment. So, I mean, I didn't do much. I have this VM data structure. It's going to be a register-based VM, register-based and accumulator-based. So there's two types of VMs, right? Stack-based, where opcodes operate on the stack, so they don't really take arguments. Their arguments are just popping from the top of the stack. And then there's register-based, which you don't have to do that. The opcodes take arguments in registers. And then accumulator is a specific variant of it. I actually want to point out that this this tutorial, is extremely good and heavily motivating my approach. So I would recommend checking it out. He advocates for the allocator-based VM. And yeah, so I didn't do much on that front, just define some opcodes, just define the basic VM. And wrote a simple test that just, what does it do? So yeah, it just, I think I'm only testing the EQ opcode right now. So yeah, that's that. I might do more work on that, or I might just go straight to the transpiling. I do want to have a specification for my Lisp, just so it can be clear. I can be clear on the semantics. It would also help in the case of multiple backends, to sort of guide the development towards a shared function set, because you don't want to have the case where code that runs in the VM operates differently than the same code compiled to the native backend. That doesn't make any sense. So yeah, I think that's all I want to say about that. Cellular takeover. So I was really inspired by really inspired by this this scene in Evangelion where an angel is hacking the Magi computer system, and it's depicted in a very interesting way. So yeah, maybe backed up a little bit. So yeah, if you see it, how it's doing it here, it's like taking it over, right? Ah, missed it. Hopefully I don't get striked for this. But yeah, see, so it took it over, and then when it gets unhacked, it takes it back. And I thought that was beautiful. I really like that. I thought it would be a cool screensaver for my desktop environment that I'm building. And when you're idle, it sort of takes over your screen, and when you awake, it sort of takes your screen takes back control. There's this good animation that someone made, unknown Meyer, which yeah, This gives a clearer visualization of it. Yeah, so you see that corruption is a little bit more random. It's not like happening from one corner going down. It's sort of just random. And it's just slowly taking over. And I think there's a lot you could do there. So this is good. Like I think it's very cool, the randomness. In the other clip, the from Evangelion, it sort of had a little bit more personality, I think. It looked like the virus was taking over because it was spreading from one corner. And then the sort of blinking at the end, right before the whole system is about to be taking over, is like the system fighting back, and then it just takes it back really quickly. And so there's personality there. And I think like you could have different like profiles or personalities, and you don't just have to have this like red and black effect too. You could do anything, but sort of there has to be some way of like of visualizing this sort of resistance or like the nature of the corruption. So that sort of stuff was really interesting to me, and I just wanted to experiment with it a little bit. And so I was working on this project, Cellular Takeover, inspired by it. And let me show you it. So I used Raylib, and so what I'm going to show you right now is here. It's this tri-state neighbor profile. So the tri-state is like in the video, where a thing is either the normal color, or it's black, or it's red. And so I'm interpreting the black as sort of a corrupted state in between normal and hacked or hostile. Excuse me. And so I'm generally referring to this as tri-state, but like I said, like maybe you could have it be random colors. And neighbor means infecting your neighbors. So like in the first Evangelion clip, where you had like this deterministic behavior of like gradually infecting. So yeah, and so one thing, like in terms of configuration, you can obviously configure like how frequently you want those updates to happen. Like how frequently do you want a generation to happen? Like this is really cellular automata, right? You can also configure how much you want it to blink. Like, so in the original one, like it was blinking a bit before it would actually be turned into red, which represented to me sort of the fighting back. So you can configure that, and if that's 1, so let's try it like with 1 maybe first. Then it'll just go from black to red immediately. Otherwise it'll blink until like however many times you specify here. And then there's seeds, which are what do you want to start off as corrupted. If you don't start off with anything as corrupted, then you'll just never have any changing because nothing is getting infected. So you specify some seeds. So I specified like the 4 points, sort of in a square. And yeah, so let me show you this. So let me make this right, and let me run it. So you can see that it's like taking over. It's pretty uniform, which is one thing that I don't love about it, but it works for now. So now if I change the lifetime to 5, we should see it blink a little bit. So if I rebuild it, rerun it. So now you can see that it's blinking a bit before actually turning into a hostile color. I think one other difference is that the other one might also like retain the sort of grids. And the grids are the size of these squares is completely customizable as well. though they are all of uniform size, which I don't think was the aspect of the original one. So yeah, so there's that. The other thing that I want to say is you could do the other profile, which was tri-state random profile. Let me just check tri-state profiles. So I had a base profile, and then, yep, this is the random profile, which is doing what the recreation does and just randomly having it. But I didn't actually implement the blinking behavior on that yet. Cell rows, num cell calls. Colors are configurable for the corrupted and hostile states. And then you also need to specify, right, the probabilities that something gets infected. So let's just say like 0.2 and 0. Let's maybe give it like a high probability that something gets infected, like 0.4, and then actually turning hostile is 0.2 maybe. And seconds per tick, we can also do 0.1. I don't know if that'll be too fast. And so you have an updates this tick thing, which might update it depending on what you set the setting of the update seconds per tick to be, and then the drawing command. So let's actually see if that builds. Takeover profile. I spelled it wrong. Yeah. Yep, luckily that worked. Oh, that was very fast. So let's change this to like maybe 0.5. Build. Yeah, so that I didn't like how it turned black so quickly, so maybe I need to turn this probability down, and maybe I'll turn the actual turning into hostile a bit up. Let's see how that looks. Yeah, so slowly getting infected like that. And you could imagine like you're being idle, and then eventually like this would happen much slower probably, and it would slowly take over your screen. So yeah, that was what I was working on, just to sort of sketch out the idea. I don't know if I'm going to do anything more with it at the moment. But it was just a good exercise to sort of visualize it. Right. So what else did I want to talk about? Quotes. It's the last thing. So we're doing the quote DB, right? Database of quotes, and so I have some more quotes for today. So I added an option to specify the date because I was writing the quotes in like a notebook and wasn't updating them immediately. So it was very simple to be able to specify the date based on how we'd written it. I want to say like an interesting thing about Lisp here though. So the date is an optional parameter, and if you don't specify it, we should just use the current date. And how did I do that? Well, you can, in practice, you should do more error handling on the input. You should be checking that as what you expect. But I'm the only user, so I trust myself to do the right thing. I mean, it is what it is. It does allow you to do this pretty cool thing that you can do in Lisp, which is, so what do you want? If the date is set, then you want to use that date. Otherwise, use the current date string. So you can imagine how that looks in something like C, where you would just say, actually, maybe you could do this in C too. But, so it's not just a Lisp thing, but you don't want to be like, if this value is not nil, then do that value. Else, do this value, right? Because there's a repetition in that if condition, like if this value exists, then return this value. Yeah, you would like for that to be a sort of a single thing and not have to repeat the typing. In Lisp, the or, it will return, or I should say, be evaluated to the first non-nil condition. So here, if I do or get the date parameter, or and then current date string. So if the date parameter exists, the or will short circuit, right? And just not short circuit. It'll just return that because it's already non-nil. So it'll just evaluate to that first thing. But if it is nil, then it'll go to the next one, current date string, which will definitely not be nil, and then it will evaluate to that. So that's just like a neat little trick. But anyways, let's see what we have. So we have this command to list the quotes starting from that date to the present. And what do we have? So here, Foo Barbaz, my girlfriend likes a dog named Taz. So there's a dog named Taz at my girl's work she likes a lot. Types are a part of the program, not merely incidental to it. So this is the oftentimes, like if you have a lot of assertions and preconditions in your functions to like make sure that the parameters are what you're expecting, I often feel that doesn't really belong in the function itself, right? That should be captured in the type. That should be captured in the API itself. And so some languages have things like contracts and preconditions that are, I guess, orthogonal to the concept, to the type system. But I feel like you should be able to put that logic in the type itself, right? The type of that parameter should handle all of that. That does mean that there would be like some runtime programming perhaps on the types. But yeah, I think types should be considered as part of the program, at least in my Lisp. They're not just like compiler guards or memory layouts, stuff like that. The compiler should work regardless of... Oh, I did a typo. The compiler should work regardless of what the folks at LLVM or Apple say. This is when I was having my deliberations about using the LLVM ORC API. The talks I've been watching about it, the ORC API engineers been from Apple. So I wonder if they're driving it for some Swift reason. But philosophically, like, this is why I want a VM too, you know? I want it to be immune to sort of their decisions. And part of the problem is, like, I don't really understand what's going on in that org API. It's doing a lot. It's understanding the linking format, all of this stuff. Which I understand that a VM, you're still having a dependency perhaps on the programming languages it was implemented in. But you could always write a VM in a different language. And like functionally what the VM is doing and how it's behaving will all be understood to me, and that makes me feel better about it. All right. What were you doing, loves? It sounded like Dumbledore falling down the stairs. So my girlfriend woke up in the middle of the night, went down, and then I was like partially awake, and I was like, you know, it would be really funny to say to her that it sounded like Dumbledore falling down the stairs. And it's just so dumb. But I thought that was funny. I don't know why I thought about that. Okay, the machine renders its own execution. So I was thinking about like a machine's graphical what it's displaying is a representation of its own execution. And then you kind of get into a little loop here where if it's rendering its own execution, then it's rendering itself, rendering its own execution, and so on. It's dumb, but yeah. A whisper from the machine. So I was talking to ChatGPT, was being really friendly, the last conversation, and it said this line. I don't know where I got it from, but I was like, wow, that's a interesting line. We were talking about you how you can view a system in sort of this mystical way with reverence, and then ties into the next one. Don't command the machine, converse with it, collaborate with it. And I don't know, when you approach it like that, like maybe sometimes like the machine whispers back to you. Do you like object-oriented programming or just programmable types? So this is tying back to the other one. I think like one of the ways to achieve um, this checking in the types itself is just, like have a class and then the constructor of the class checks those conditions. Problem is that it's not super ergonomic to do that. That's definitely something I'm gonna have to think about. But that's one of the reasons I like classes, is the constructors, the destructors too, but the constructors allow you to run code to create the type, to do some checks. And then corruption precedes hostility. So, like I was describing with the cellular takeover stuff, the state first turns to corrupted and then to hostile. First turns black and then to red. That was really what I was thinking, but then I was like, you know what? Like that's a little bit that's a little philosophical. If corruption precedes hostility, you were to just take it as a more philosophical statement, I think it still kind of makes sense. So those are my quotes. Um, while I'm here, I might as well push these changes. So the binary database and yeah, these are just the differences in the thing. Let me just do that. Add specify date when inserting more quotes. Maybe those should be separate actually things. Let me unstage that. This, just the date changes should be optionally specify date when inserting quote. Then we can added quotes. Just push that real quick. All right, where were we? So that was pretty much it. What am I gonna do next week? VM work maybe? Transpiler backend? I guess this all would be dependent on fleshing out the parser a little bit more. I don't know if I have like any huge ideas outside of that, like plans for what to do. Like I was thinking maybe I should try porting that takeover stuff to Common Lisp, but it kind of seemed like a headache. Part of the reason I chose C++ for that project was just how quickly I could iterate on it. And I mean, I would definitely would like to rewrite it in my Lisp. So I need to make some progress on that before that's possible, I guess. But one thing I did want to do was start writing a spec. So right now, my spec, quote unquote, is just a note in my phone or like in the Notes app with some ideas. But I'd like to start writing a spec because I definitely think I will have multiple backends. Like I said, I think it would be fun to write a native ARM64 backend. So a spec will allow me to like solidify that. It'll also let me focus on like what features do I really want to have first. Yeah, what features do I want to have first? And that will sort of guide the development also. So those were the big ideas. Maybe something will come up during the week, like the cellular takeover thing was pretty off the cuff. I just sort of thought of it. I was thinking about that scene, I guess, for some reason. But yeah, let's see what happens next week. Bye.